actual data to get the physical model. So if the physical model change, we can adapt the physical model to a new. So in that way, you can make it adaptive as the system change. Of course, Simin also mentioned that you need to know that the system is in a normal state. Because when you learn the model, I mean, that's when you say this is good behavior. So you need to be sure about that. But for sure,
machine learning
or
behavior.
System identification. I mean, you can certainly make these models adaptive.
Yeah. But they are not at the current stage of your research, or they are?
In the examples I had here, they were indeed static. I mean, we fixed the model and did our experiments. So there will be another. You need to add another layer if you would like to adapt the models. Yes.
But that is the way the research are heading.
Yes.
Or?
Yes.
Okay.
Yes.
Mm-hmm. So, Vidar, what's your view on re-engineering as an option to handle the aging of ICS? And is that cost effective?
Yeah, I think it should be. I think this is a very good question because we have to these are the kind of question that we have to ask based on this study and other studies. So I'm asking this question myself. What's the remedy? What's the remedy? That's not very obvious to me that this would be functional, but it sounds to me that it would be cost effective if it is functional.
Yeah.
So, yeah.
If you look at the Gallup we made here about the audience, 90% actually tells that all devices are a problem for security.
Yeah.
So the awareness of that we have all devices that are vulnerable and highly critical for the security is there. But still, when we're out in the reality, we see a lot of old equipment that are not supported and old versions and not updated and not patched.
It's depending as well what industry. I mean, we had a set of industries that internally are quite different. So if you ask one that's producing things, I mean, they have shorter scan times and everything, and other problems with aging. And if you ask someone that's just monitoring, the problems perhaps don't arise at all. So it's very the picture is very differentiated, I would say.
Isn't it also that Erwin, in his presentation yesterday, that he pointed out some of these very strange anomalies that are in this field, that is easier for management to accept to changing a box of PCs, a bunch of servers every third year, that is very expensive,
yes.
than to change something that is out in the field or part of the SCADA or part of the actual process.
Yeah.
That will be something that they are very hesitant to do because, for some reason.
Well, if it's working, don't touch it.
Yeah. So is that also what you have seen in your questionnaire and your research?
Yes, of course, and that's why we say that security as a concept, security compared to safety, is something that forces you to take a step back and just look at the whole structure. So that might be the upside of the new world that we're facing.
So if we make a general question for all three of you, how do you see the correlation or the impact or the line between safety and security in your different research areas? For example, in intrusion detection.
Very relevant question. Airbus Group, which you would normally associate with airplanes, they are looking at this SCADA security extremely just now at a great extent. And actually, Chris Johnson has a paper about safety and security. I would recommend you to read it because he discusses the differences in the culture. It's very different to talk about security and safety. In safety, you have total transparency. Everybody is actually disclosing stuff because that's good for everyone. Security, you have total blackout. Nobody will disclose anything. Nobody wants to even confess that they've had an attack. That's one of the problems. The other difference that you can actually quite obviously see is that when you have a security breach, at least in certain law enforcement situations, you're saying that this is a crime scene. UK says it's a crime scene. You shouldn't touch anything. You shouldn't, you turn it off and nobody should do anything. Whereas in safety, everything should, operations should continue. Nobody should actually turn off anything. These things are not going to be easy to actually deal with.
No, it's a confrontation.
Yeah.
Henrik, do you see that in your research area? Do you have that as a parameter that you have to work with?
It's actually a little bit interesting, I think, because these anomaly detection schemes that I've been using, I mean, at least to me, it seems that they were originally introduced to obtain some sort of safety. I mean, you find these ideas for a long time in power systems, bad data detection, for instance, in SCADA control. I mean, it's basically the same idea I presented, and the idea was to localize failing equipment.
So sort of retrofit them into the security
we're using this
arena.
I mean, what we're saying here is that it also gives you some security in a certain sense, but because, I mean, these tools are there to find randomly failing equipment, but it also puts a lot of restrictions on the attacker because he also needs to
Defeat them. Yeah.
Yes, but of course safety is broader than just finding equipment. But it's not an easy. I think sometimes security and safety is aligned. Sometimes it's maybe orthogonal even.
Yeah.
You would like to add something, Vidar?
Well, we work with the whole scale from natural disasters to war, and somewhere in between. Security becomes more important than safety, and this is a field where I experienced that it's not that clear what's the big issue to me. I'm more comfortable with safety than security. But
Simon, you mentioned the difference between safety and culture, and I saw that there are also questions here also about transparency. Here's a question: isn't the operators of critical systems scared of having researchers in their environment?
Good question. It's all about trust, so you have to build trust. But I actually had 3 people in my group, myself included. We went through a one-day course. The course that everybody has to go through for safety, electrical safety, in order to actually set their foot in a substation. So that's before I could go to the substation, I had to actually take that course. I guess you're always accompanied by people. I don't think we could do any harm to their systems. And definitely when they ask me, well, it seems to be possible that you could just put a laptop here for 1 week, it doesn't disturb anyone, and if you could just take a cable down and from the port replicator, I say, I'm not going to take the responsibility for operations of your systems. Actually, you have all interest to know what your business is and what things are flowing through your system. Why don't you do it yourself? But then you have all these problems with, they have to have supply chain issues, they have to have some guy, some other person who knows about these very complex things which nobody knows how they are configured, and so we get into problems. I mean, I cannot really go into their networks. I wouldn't take the risk of doing it. But some of them are very happy to talk to us at least.
Vidar and Henrik, what is your opinion on that? I mean, talking to you is maybe one thing, but interconnecting and things like that, being inside the systems and getting more close cooperation, is that a problem? Do they reveal things to you when you come with the questionnaires, and do you feel that they are interested in the results, but they don't really want to participate? Or what is your?
I think that some of the questions that we ask them, they wouldn't answer if I weren't from an authority or
Government
you know,
agency.
Yeah.
Yeah.
So.
But if you were an academic researcher, they wouldn't have asked.
Yes.
Or?
Yes.
Okay.
Perhaps. I mean, I was a consultant before, and we worked with the safety and security, and we wouldn't have been able to just go out on the field collecting opinions like Microsoft. That I mean, the quotations that I showed you, those wouldn't have been popping up at all. So there is it's about trust. It's a question about trust, but there is a will of contributing, I guess. Yeah.
Yeah.
Yeah, I mean, there is a reason. So my final case study, this Nimbus microgrid, where we did this attack against the combined heat and power plant. It's the reason I said it was a simulation, because, I mean, the owners, I mean, if you say you want to try out an attack on the sensors, they get quite nervous, right? But they did allow us to make a very detailed model of it and simulate it. So maybe, I know, some very...
Sometimes as a way.
I think it's a way towards convincing them that this might not be so dangerous, but we're not there yet. So indeed, if you say that you want to try some attacks in their expensive infrastructure, they're not necessarily happy. But I mean,
so it's trust, and trust. You have all said.
No. But actually, that's the reason why you need the test beds. Because in a test bed, you can do repeatable experiments, you can do attacks. Nobody's hurt. Nobody's systems is disrupted. This is a very good reason for actually studying attacks, studying the time to take one point, attacking one point and seeing the propagation to another point. How long does it take? Once you have a defense in place, which defense is better than the other against this attack? How long does it take to recover the system from this? All of these things you can study in test beds. You cannot do it in real systems, and you cannot, of course, do it to the same extent in simulators. If we fail in this, I mean, I'm going to spend as much time as needed to actually do all what I think I can do to get this testbed going. If I find that this will not be possible, well, of course, I will resort to simulations and building my own little toy networks inside the university and doing my work. That's what, the options, basically. Yeah.
Great. Okay, a question here for Henrik. How do you distinguish an attack from some anomaly in the system? And how do you know you detect the attack?
Yeah, I referred to that in my talk. Yeah.
That's a good question. I mean, that would require some additional analysis of the, I mean, these anomaly detector, what they generate, it generates basically predictions of what components are failing. And maybe by looking at that, you can try to realize if this looks like an attack or not. I mean, if it looks very coordinated, for instance, if two components fail simultaneously in a very spectacular way, and you see that in these anomalies, then maybe it's an attack, right? But if it's just a signal that disappears, it might be a fail. But I mean, there's no, you will need to sort of learn, you need to teach the anomaly detector to react. So the anomaly detector basically, it gives an alert. It basically says there is something misbehaving. Then you need to do further analysis in order to, but maybe Simin has more.
You have the two you have to distinguish between attack detection and attack diagnosis. There are different techniques, and attack diagnosis needs a lot of knowledge about your system. So coming back to the cause of an attack is a different thing compared to the, and that's why I was saying that amongst the bad things that people mention about anomaly detection is that, okay, just getting an alert is not good enough for me. And we say, well, that's a good start, and let's see what we can do with it then. So, yeah.
Okay. So, Simin here, what is your requirement on test beds?
What is your wish list?
Oh, of course, thank you very much for this question. we've been in discussion with 2 operators, one in the water area and another one in all-in-one central heating for whole town. They both are very interested. One of them is going to collect it in their own network themselves for their own knowledge because they think it's good for them. We'll see where we go with that. And then, of course, from getting that data from them to us, we have to do some things in between, and we won't replay that same data in the crate environment. We have to do some things with it. The other operator says we have a pilot system, and in there we have some Siemens equipment that it has some image. You can actually port imaging, and we really say anything goes. If you have anything that you would like to collect data on yourselves, we would be very happy to be your discussion partner and even to some extent help you with the technical abilities if you need, but I'm sure that you need to do it in your own networks yourselves, and which part of your networks are less sensitive, which parts of networks you really would like to have more information is up to you. We take files from your system and go away with them, or we take files in your systems and do some desensitization and then move away with them and then start playing it in this emulated network.
So Simin, if you look at the Gallup here, we have a question. Do you monitor and capture any infrastructure data in ICS environment? It looks like 2/3 of the answers actually do monitor the ICS environment. And this is a tricky question, though, because one thing is that you're logging the SCADA and data from your environment, but what you are most interested in is the infrastructure, the data from the switches and firewalls and stuff like that. So you see the flow of the data.
That's right. I mean, the SCADA systems do a lot of logging, and I mean, you could, in principle, you could build all the security. That's basically some of the trends we're seeing, that you build all the security inside the products that these companies are selling at very high prices, and you can build it inside those, but then you have to have the knowledge actually to know what this system gives me, how can I use it, how can I interpret it, and all that security knowledge should be in the operation of the SCADA system. If you don't have it so far, or if you prefer to keep the control separate from the security, then you have to add the security boxes in, and the security boxes, of course, need to do extra logging on top of what you need for controlling the process.
Guys and girls in the public, could you please help us in filling out the Gallup? We have just 9 respondents. So this looks like we have a very good situation. We have a lot of good data for Simin and the others.
Yes.
Is this really the case? Are you really truthful?
It's not really the case what I see
It looks
when
a
I
bit
look.
skewed to me, because they would have a lot of data to work with, because if you are doing all this type of thing. But is this really a picture
Talk
that
to me
reflects
after.
reality?
Talk to me.
Please.
Now we see another picture here.
I didn't say that everyone should go, no, but please send in what is your real situation.
It's interesting to see. It's like the data I do.
Yeah. But there is more on both sides. That is good. So we get more respondents, and we get better results than just 9 respondents.
So please help us with this.
Yeah.
And we can share this with you later on, so you can have that as an after the summit. So we'll
But it really
give you
still looks better than I would expect. So it's like 50% on each.
go.
Yeah, go.
Yeah, you were more keen on the quiz than this Gallup. Continue to answer this. I will have. Do we have more questions on this slide? No, but we have on the other side here.
When will your work be presented? When it's be finished and presented? And I think that goes for everyone, but this was for Simin during her
Our project
talk.
runs for 5 years, so
And you are on year...
in the beginning of the 2nd year.
Okay.
So we've got 4 more years to go.
Okay.
And you guys? Are you finished with your research?
Yes,
or is it part of a
this
bigger
is
program?
one of several studies that we do. So
This is one result.
One result, yes. It's finished.
Okay. And it will be available, it is available right now, encrypted in Swedish.
It's a brief in English. The report is in Swedish.
Yeah. And Henrik?
Yeah, so our research, it's a program running in parallel with the Siemens project, so it's
Also
starts
5 years?
5 years. It's been 1 year, and everything I presented today, it's either published this year or it will be published next year, so it's submitted.
Yeah. And we have one of your colleagues that is part of the program that's going to present later today, right?
Yes, correct.
Roberto?
One of Mats Dam's collaborators,
Yeah.
I think, is here to talk about embedded
So
devices.
that is also one of the things that you're working on in the project.
It's not. I don't think it's directly connected, but it's about embedded devices for sure, and about you will see more about it.
Okay. So now we see the Gallup have changed. So now it's not the
Rosy picture.
two-third, and we here have the old systems
Please,
problems.
get if you could add, yeah.
And then we have, can we really do attack detection? Oh, yeah, so we have 13 votes. You can please send in more right now when it's up here. Otherwise, we will have
A lunch
a
break.
couple minutes to the lunch break. But first, we will thank our research session here. Give them a hand. And before you run out to lunch,